Hello students, welcome to lecture of Kinematics and Theory of Machine. Myself Professor Patel, and we are going to continue Chem, and in this chapter we will complete the examples of Chem profile, which is very important because in every exam, GTU exam, always there is a 7 marks numerical is there, and which is totally graphical based. We have to draw the Chem profile in this numerical. Okay, let's start. So first of all, you can see here given data for that example. So let's start. A cam with a minimum radius of 50 mm means it is a minimum radius of cam 50 mm rotating in a clockwise at uniform speed is required to give a knife edge follower. Knife edge follower is there and motion as described below. So first is to move outward through 40 mm means lift or stroke is a 40 mm and angle is given is a 100. Okay, for 100 degree means for rise angle is 100, and for that follower will move upward direction is a 40 mm, and then for next 80 degrees the follower will steady means at a same position at a top, which is a dual theta 2, and return start during next 90 degree means after that 180 this for this 90 degree follower will return, and distance it will cover is a 40 mm. Okay, and to dwell for the rest of the period 90. So the displacement of follower is take place uniform acceleration and uniform retardation. So always remember that before starting the cam profile you have to understand which type of motion is there: uniform velocity, uniform acceleration, simple harmonic or cycloidal. There are 4 types of displacement diagram is there, and we have to understand which type of displacement diagram we have to draw for the follower. So in this case, rise and return, for rise and return same diagram will be there, uniform acceleration, but in some example rise with uniform velocity and return with simple harmonic, and sometimes rise with a simple uniform acceleration and return with simple harmonic. So this type of combination can be asked for rise and return. Okay, and the line of stroke of follower pass through the center of cam. First of all example I can divide in a 2 category. One is a radial cam means line of action of follower pass through the center of cam, and in sometimes if there is a there is a offset is given, offset cam and follower are there. So in that case follower is not pass through the cam center. There is some offset distance is given means eccentricity is there. So that type also example we will study in the next lectures. Okay, let's start. So first of all, what is the given data from this? So you can see here the minimum lift is given 40 mm. You can see outward direction 40 mm, rise angle theta 100 means during 100. After that you can check dwell is a 80, next 80 degree means dwell angle theta 2 is a 80 degree, theta 3 you can see here to return the starting position, it is a returning angle, that's why it is a return angle 90 degree. After that dwell for the rest of the period. So first of all, before starting the cam profile we have to make the displacement diagram. You know that displacement diagram. So this is the 5 data we are always required for the drawing of displacement diagram. Okay, and RB means base radius or minimum radius. Okay, this is RB means base radius or minimum radius. Okay, is a 50 mm which is required during the starting of cam profile, but right now we need these 5 data for the displacement diagram. So first of all we have to check that which type of motion is given. You know that uniform acceleration is given. Okay, so these 3 data always required. We have to check in a given data which is this uniform acceleration, type of displacement diagram depend on this. Which type of follower? Means there is a three types of follower in our numericals are there. So one is a knife edge, second is a roller, and third is a flat face. So these three types of example are there. So first of all, check which follower is given. You can see here the uniform knife edge follower is given. Okay, and in which direction is follower is moving. Check this, which direction? In clockwise direction. Remember that if cam is rotating in a clockwise direction, our cam profile we will draw in an anti-clockwise direction. Why? Okay, when I'm starting the cam profile, I will show you how it works and how it's we take the opposite direction in a cam profile. Okay, so remember that whatever direction is given, we draw the opposite direction for the cam profile. And remember that if this direction is not given, we always assume that the rotation of cam in a clockwise direction, so we are drawing a cam profile always in an anti-clockwise direction. If in example there is a given that this cam is rotating in a anti-clockwise direction, then we have to draw the cam profile in a clockwise direction. Okay, let's start. As we already know that how to draw the displacement diagram, okay, I will skip that, but I will revise a quick review of how to draw uniform acceleration diagram. Let's check. So first of all, you know that we have to make the right angle. Okay, and size of this right angle, you know that depend on height of this rectangle is depend on this length, which is a 40, so 4 centimeter will be there, and this length will be 18. Okay, after that you are going to divide this rectangle in 4 parts, because our scale is a 1 centimeter is equal to 20 degree. 1 centimeter is equal to 20 degree. So always remember that 100 degree means is equal to 5 centimeter. After that 80 degree is equal to 4 centimeter. 90 degree is equal to what will that 4.5, and again 90 degree 4.5. So we are going to divide this rectangle in these 4 parts. Okay, so like this. Okay, I am roughly drawing that and very in speed because it is revision. And then we are going to divide rise and return in 6 parts. Rise and return in 6 parts, you know already that. Okay, this 6 part and 6 part of returning angle. And after that, you know, in a uniform acceleration, what we are doing, we are going to do, we are going to divide this center line in 6 parts again. Okay, these 6 parts, same as here, 6 parts, like, okay, equally 6 parts, means 4 centimeter divided by 6. Okay, whatever the answer is. So after that, what we are going to do, connect this line here and top 2 parts at the end, and bottom 2 points at the bottom. And after that, we are going to connect these points, this here A, B, center will see these points, and we will make this graph which is uniform for the uniform acceleration. Okay, so this is the diagram we obtain, and in this diagram you know that which this distance we are using during the example is distance between 1 and B, 2 and C, 3 and D, 4 and E, 5 and F, and in case 6 and G. This distance we need during the cam profile. So make this very carefully. Okay, let's start how to make cam profile. So first of all, you know that there is a this base radius is given. So first of all, I am going to make circle of 50 mm, means 5 centimeter. In this case, we don't need to take any scale here, because in cam profile we are going to draw cam profile in a 1 1 scale, original scale. So 50 mm circle. After that what I am going to do, center line, from center one vertical line is there. So our cam profile will start from this point. You can see this point here, and after that I am discuss this cam rotation in a clockwise. So our profile will start in a anti-clockwise, because if we make this cam profile in anti-clockwise, when cam is rotating in a clockwise, it will give this data. So remember that when is rotation is given in clockwise, we are going to start in a anti-clockwise. And how? So first angle is 100, second is a 80, third is a 90 and 90. This total is a 360, and we are going to divide this circle, means 360 degree, in these 4 parts like this. Okay, so first is a 100, second is a 80, after that 90 and 90. So these 4 parts of circle I have done based on these 4 data. Okay, so this angle here is a 100, last angle is a 90. So that's how all these 4 angle. So in this case we have to make base circle, divide base circle in 4 parts as per given data. Now same as in a displacement diagram, what we are doing to we have done in a displacement diagram. So same as in a displacement diagram, we are going to divide rise or outer stroke and return stroke in a 6 parts. So same will be here, which is the rise and return. You know that. So this 100 degree is a rise and this 90 degree is a return. So we are going to divide this arc in a 6 parts. How? 100 degrees there, 100 divided by 6. So we are going to divide this 100 degree in a 6 parts. Okay, so we are going to start dividing the rise and return. So 100, this 100 divided by 6, so it will be 16.67 something. So we use the protector here and divide this 100 degree in a 16.67. Okay, let's start. So I am dividing this, and in this next, this is the theta 2, you already know that, and it is a dual. Dual means we are doing nothing in this dual period. Okay, you know that in displacement diagram also is dual is always in without any changes, we kept that as it is. Same as in a cam profile, in dual period, this dual we are going to do nothing, because in dual cam follower is in a steady condition. Okay, so it is not moving in a dual angle. After that next angle is a 90, 90 divided by 6. So 90 divided by 6 is a 15. So we are going to divide this theta 3 in a 6 equal parts by using protector. Okay, we don't know the points on these lines, these 6 parts we have get some points on that, so we make the length okay, and which must more than the rise. Okay, so length we know that it is a 40, so this line will be more than 40 after this circle maximum. Okay, now give the points same as here, like you have given the point 0, 1, 2, 3, 4, 5, 6 for the rise, and the 6 part we have already there for the return, 0 dash, 1 dash, 6 dash. So same point we will give here. So first point will be this, here 0, this point is a 1, 2, 3, 4, 5, and last line will be 6. Same as here, because starting from the 0 dash, okay, I am going to give here 0 dash, this will be 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, and last point is 6 dash. So same point as you can see here. These points I are giving the number same as the here, and after that this is the I'm going to revise up to this point, and after that our chem profile, drawing of chem profile will start. So up to this point what we have done, make the circle of a size of the base radius, divide this circle as per this 4 angle, and in that 4 parts, this 4 portion rise and return divided by 6. Okay, now what we are doing, we are going to do here, these positions you can check here. What is indicating this? This is indicating that as per as this cam is rotating, this degree is increasing, the follower is moving upward direction, and after this 100 degree this follower will be at top, means at a 40 mm distance from its original condition. So we are going to obtain this linear profile on this circular profile. Okay, what we are want, this displacement diagram is in linear form, we are going to obtain this in a circular form. How we can get this? So first of all, check this. We have to use as here compass. Okay, we use the compass here, and we know that 0 and A on a same point, so our A will be here. A point we will get here, A point. After that, check here, the distance is given between 1 and B. We take the center at 1 and take the distance to the B, and take this distance we apply from 1, and here we will get some point B. Okay, name this point here as a B. Okay, same we are going to do here from distance 2 to C. So 2 here, and center, take center, and distance will be C. Okay, same as a D, this distance will be E, F, and last distance you can check here, this distance from 6 to G. So 6 is here, and distance will some point we will get. So these points is very important, and name that points like C, D, E, F, and G. Okay, after that you can see here next 80 degree in displacement diagram, follower is in steady condition. So we are not going to do anything with this, and after that we are going to start for 0 to H. Distance is here, so there is a 0 dash. So 0 dash to H dash distance we will get something here, H dash. After that you can check here, the distance is from 1 dash to J, 2 dash to K, 3 dash to L, 4 dash to M, and this 6 point here. So this all distance we are applying here. You can check 0 dash to, this is the distance you already measured from the 0 to H, and you will get the H point here. Here will be H point. Okay, same you can get here H. After that H is you will get J, K, L, M, N, and at the end there will be P. Okay, so give the number J, K, sorry, okay. we are almost complete this profile. Now nothing but we are going to connect all these points and we will get the cam profile. Okay, smoothly connect, sorry. So we are going to connect these points and we will get this curve on this circular path and we will get this cam profile. Okay, this G point. And so in this G to edge there will be totally, you can make from center to as circular, perfectly circular arc, because follower is not moving during this dual period. Okay, and this is your cam profile. So this is your cam profile. Okay, let's check again. I am revising that. First of all, what you are going to do, take a circle, make the, okay, what you are going to do, first of all, check this, make the circle of this 40 mm. After that, divide this circle in a 4 parts. Make the one circular center line here, and this center line will be reference for all angle. Make this center line, and first angle will be here up to this point, you can check 100. After that, this is 80 and this is 90, and 6 parts of this rise. Okay, 6 parts of this return, and give the number. Numbering is very important in this chapter. If you make perfect numbering, the chances of mistake is very less here. Okay, 0, 1, 2, 3, these points will be 4, 5 and 6. Same as 0 dash here, 0 dash, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash. And after that, using this distance here, 1 to B. So 1 to B is here, 2 to C, 2 to C here. So take this point, we are going to make some arcs also. You can make the arc here by using compass, and same as here, and you join all the points and you will get this cam profile. Okay, thank you.